Hi, this is Raj. Welcome back to the ETL specialization course on SCD Type 2 demo. The session goals are: this demo session on SCD Type 2 deals with simple use case part 1, where the dimension table depends on only one source table. The dimension table is named as dim underscore staff and the source table is named as staff. The source staff table stores the person details working on a DVD rental store. The goal of this session is to capture the changes in any of the staff attributes and retrain the history of changes that have occurred in staff attributes in our target dimension table. The key point to be noted is this staff table is used by an application which, whenever it performs a delete operation, the corresponding record would be deleted physically from the source table. So when you query it again in the source table, you can't see that deleted record. So what are the prerequisites for this demo? Watch my introduction session on SCD Type 2 to know about what is SCD Type 2 and what are the other demo use cases that we are going to discuss as part of SCD Type 2 module. Then watch my session on timestamp based CDC technique to know about what is the incremental data loading concept which is used as part of this demos. The Pentaho Kettle tool, and then the Postgres database server and the client tool to interact with the Postgres database. Now let's move on to the hands-on part. So this is the table structure of our source table staff. You can see the natural key or the business key of the source table is staff ID, and it contains other fields such as first name, last name, address of the staff, email address, store in which the staff works on, whether the staff is active or inactive, what is the username, what is the password, when the record got updated for the last time in the source, and any image. So these are the attributes which this source table holds, and our intention is to capture the history of changes that occurred in any of these fields into our dimension table. Let's move on to see what is our dimension table structure. So this is our dimension table, which has the primary key or the surrogate key of staff key, followed by the key fields or the fields which we are interested to preserve the history, such as staff first name, staff's last name, staff ID, the business key at the source, staff store detail, and then the following other attributes are related to SCD Type 2 handling operations such as staff version number, staff valid from, and staff valid through. The version field shows the version of the dimension entry or a revision number. The valid from and valid till dates are the field names containing the validity starting date and the validity ending date. So let's move on to the transformation designed for handling this SCD Type 2 technique. So as part of this transformation, we have the first transformation entry as to capture the maximum last updated date that has been made as an entry in our dimension table. If there is no such record, if there is no record in the dimension table, then we would default it to a constant value. This is for timestamp based CDC technique to work on or to incrementally fetch the record from the source table. Then the next step, we select data from the source staff table with a filtering condition as last updated date greater than the maximum date or the default date selected from the target dimension table. So this would take care of fetching the incremental data load from the source table or identifying the attributes which got changed from the source table. Then in the source we have the active field as a boolean data type. So we are converting it into string because in the target dimension table we have this attribute of string, so we are just converting that field to string using this select value step with the metadata field tab. And then using this value mapper step we are just mapping what is the source value and what is the corresponding target value which we are converting as a boolean to string and storing in our dimension table. Then the final important dimension lookup or update step where the whole SCD type 2 operation is being performed by the pentahookettle tool. So let's go more into details about this dimension lookup or update step. The first entry as part of this dimension lookup or update step is step name, which is the name of the step. This name has to be unique in a single transformation. Then update the dimension step. Enable to update the dimension based on the information in the input stream. If not enabled, the dimension only performs lookups and adds the technical key or the key from the target dimension table to the stream. Connection. This field holds the name of the database connection on which the dimension table resides. Target schema. This allows a developer to specify a schema name. Target table. This is the name of the dimension table, which in this case is dim and underscore staff. Commit size. The developer can define the commit size. Example, setting commit size to 10 generates a commit for every 10 inserts or 10 updates. Catching. This catching option has three other options like enable the catch, which is when enabled the data is cached in the step. Specify a value of -1 to disable catching, or specify a value greater than or equal to 0 to specify a catch size. Preload catch. If this option is enabled, you can enhance performance by reading the complete contents of a dimension table prior to performing lookups. The performance in this case is increased by the elimination of round trips to the database and by the shorted list lookup algorithm of pentahookettle. Catch size in rows. The catch size in number of rows that will be held in memory to speed up lookups by reducing the number of round trips to the database. So that's the purpose of this entry. Next we move on to the keys tab. As part of this tab, specify the names of the keys in the stream and in the dimension table. This will enable the step to perform the lookup. Fields tab. For each of the fields you must have in the dimension, you can specify whether you want the values to be updated. For all versions, this is a type 1 operation. Or you want to have the values inserted into the dimension as a new version. Technical key field. The primary key of the dimension is also termed as surrogate key, which is specified as part of this field. Creation of technical key. The technical key at the target dimension table can be created by any of these three approaches. Use table maximum plus 1, which deals with creating a new technical key from the maximum key in the table. Note, as part of this technique, the new maximum is always cached so that the maximum does not need to be calculated for each new row. Use sequence. Specify the sequence name if you want to use a database sequence on the table connection to generate the technical key. Use auto increment field. Use an auto increment field in the database table to generate the technical key. This, for instance, supported by DB2 MySQL, whereas the previous sequence is supported by Oracle, Postgres, etc. Version field. The name of the field in which to store the version. Stream date field. This is a very important field for SCD type 2 operation, where if you have the date at which the dimension entry was last changed, you can specify the name of that field here. It allows the dimension entry to be accurately described for what the date range concerns. If you don't have such a date, no worries, the system date will be taken. When the dimension entries are looked up, and also note that when the update the dimension option is not selected, the date field entered into the stream date field is used to select the appropriate dimension version based on the date from and date to dates in the dimension record, which is our date range of the dimension record, which in our demo case is staff valid from and staff valid through. Use an alternative start date, and before that we have a date range start field which specifies the names of the date or date start range for the dimension. Use an alternative start date. When this option is enabled, you can choose an alternative to the minimum year that we have used, 1970, as part of this transformation. This step is used to specify any of this following alternative start date. They are system date, start date of the transformation, empty or null value, or any specified column value from the table. Table date range n, the names of the dimension entries n range, which in our case is staff valid through. Get fields. Fills in all the available fields on the input stream except for the keys you have specified as part of the keys tab. So with this, you can see as part of the fields tab, I have specified all the field names with the type of dimension update in most of the fields except for the staff last update as insert. So it means whenever there is a change notified in these attributes which has a type of dimension update as insert, that will be created as a new record to preserve the history. This is automatically taken care by Pentaho tool, and believe me, it reduces a lot of workload if you manually does the coding part. So this is the explanation for this transformation, how it has been designed. Now let us run this transformation and see what happens. The transformation is running now, and before it gets finished, let's check over the tables at both source and target and what are the records present over there. So you can see that the source table has only 2 records, and in case of target table there are no records. So let's see what we have after the job has run. So the job is completed now, and let's select the records from the target dimension table. We can see that the 2 of the records from source table has got processed into our dimension table. If you notice, can see that the version number of each of these records are marked as 1 because this is the first version for each of these records, or the first historical entry in this dimension table for each of these records. And then the staff valid from and staff valid through fields are marked with the default values because this is the first time the record has been loaded into our dimension table, and this is how we have set up our transformation to process these records. So to grasp the power of SCD type 2 handling, let's do some updates, or let's do some changes on the source table. The update that I am going to do is, for the staff ID 2, I am going to set the active flag from true to false, and then I am going to change the last name of this particular staff to Hawks from Stephens. So let's go ahead and update this record. Okay, it's done, and let us select the record in the source to ensure the change has been done. Yep, it has been done. So you can see the last updated date field has been modified, and then let's run the transformation now. Okay, the transformation is completed now. Let's select the records from the dimension table, and now you can see an additional record which we have changed in the source table has got processed into our dimension table. The interesting point to be noted is this particular new record which has been inserted now is marked with the version number 2 because this is the second time this record has been changed from the data warehouse perspective. First change is nothing but the insertion of the record, the next change is updation of this record. And the other important point to be noted is the effective till or the staff valid through date or the timestamp has been updated to the timestamp at which this operation has been performed at the source. If you compare the staff valid through timestamp at the target as well as in the source, you can see they are exactly the same. Yeah. So this previous record is valid, the name Stephens is valid until this update operation, and then the last name has been changed to Hawks from this moment on, that is this particular time at which the operation has happened until to the future date. And then you can also notice the active field of this particular staff has also been changed to no. Earlier it was yes. So this is an example of how an update operation gets captured over to the SCD type 2 dimension table. Now let's go ahead and make an insert of new record into our source staff table with the staff ID of 3. So that's done, and let us select the records from staff table, and now we can see there are 3 records in the staff table with a new record of Hugh Jackson. So let's go ahead and run the transformation again to see what is going to happen in the target dimension table. So the transformation is done. I'm selecting the dimension table, and you can see a new record has been inserted for the staff ID 3 with again the default value for staff valid from and staff valid through. This is the first time or the first version of this particular record. Now let's go ahead and do a delete operation, because as I have mentioned as part of this demo, this is a source table which is used by an application, and when the application triggers a delete operation, it removes the record from the source table instead of just updating some flag to delete it. So let us go ahead and delete this newly inserted record of Hugh Jackson from our staff table. So the record has been deleted, and you can ensure that the staff table has only 2 records instead of 3 because of this delete operation. Now let's go ahead and run the transformation and see what happens. So the transformation is done, and you can see there is no difference between the last run and the current run, because as per the timestamp based CDC technique which we are using for handling this SCD type 2 delete operation, it couldn't able to identify that there is a record that has been deleted, and that's the drawback of this technique. And let us see how this can be tackled, or how this can be overcome using another methodology of doing a soft delete at the source instead of hard delete. So this is what we have for this session, simple use case part 1. Hope you guys learned a lot, and thank you for your time. Thanks. See you again.